All right, Chapter 6, Lesson 4, Properties of Special Parallelograms. So we have a warm-up, 1, 2, 3, 4. And here's my friend, the pause dragon. Remind you to pause your device. Go ahead and work out those warm-up problems. When you get done, press play and we'll go over them together. All right, see you in a bit. Okay, let's see how you did. So this first one, we're just gonna solve for x. So hopefully you already have an answer. I'm just gonna go ahead and figure it out really quick. We need to get those variables on the same side. I always like to move the smaller of the two. We have to use that addition property of equality. And then we divide by 4. You should have gotten x equals 4. Okay, if you did, great job. This one here, got to get x by itself. We're going to add 4 to both sides. 2x equals 94. Division property of equality. And so what would that be? 90 divided by 2 is 45. And then 4 divided by 2 is 2. 45 plus 2 would be 47. So there we have it. If you got both of those right, great job. Okay, let's go here. ABCD is a parallelogram. Find each measure. So remember that parallelogram, that opens the door, right, to a bunch of different theorems. What do we know? We know that opposite sides are congruent. We know that opposite angles are congruent. We know that consecutive angles add up to 180 degrees. And we know that the diagonals bisect each other. Okay, so just stating that it's a parallelogram, remember, opens up that treasure box. So which one of those treasures are we going to need for CD? So CD looks like a side, and we have a side here. So we're going to set up an equation, and we can just say that those two are equal to each other. So we know that CD is equal to AB, right? And so I'm just going to set those equal. So 2y plus 8, that's what CD is. AB is 5y minus 1. And then I'm just going to solve and figure out what y is. I'm going to get the variables on the same side first. Okay. Division property of equality, 3 equals y, and I'm going to use that symmetric property of equality to figure out what y is, but it wants us to figure out what CD is, right? So CD is equal to 2y plus 8, and then we're going to substitute 3 in for y, and we end up with 2 times 3 is 6 plus 8, so CD equals 14. So if you got 14, great job, okay? Let's look at this one, measure of angle C. Oh, we have to find the measure of angle C. Okay. So we have nothing for C, but what we do, we have values here, right? We know that A and C are the same, right? And these are the only values that we have. So we know that since it's a parallelogram that these consecutive angles are complementary. So we're going to start, I'm just going to start there and figure out what x is. So measure of angle A plus the measure of angle B, that equals 180, right? We're going to substitute in measure of angle A, 14x plus 34 plus the measure of angle B, which is 16x minus 4 equals 180. Then we just simplify, right? So 14 plus 16, that's going to be 30x. And then 34 minus 4 is just going to be 30. And then subtraction property of equality. That's 150. Now we're going to figure out what x is. Divide both sides by 30. We get x equals, those zeros cancel out. 15 divided by 3 is 5. So we know that x equals 5. And we need to figure out what the measure of angle C is, but I'm going to go ahead and figure out what the measure of angle A is, because since it's a parallelogram, A and C are the same. So measure of angle A equals 14x plus 34. 14 times 5. Ooh, what's 14 times 5? 20, what is it, 70? Yeah, 70. Measure of angle A equals 104 degrees. And I'm just going to say measure of angle A is equal to measure of angle C. So, you know, and so we're going to substitute measure of angle C equals 104 degrees. Because this is equal, because if it's a parallelogram, then the opposite angles are congruent. All right, so that is it for warm up. I feel like my brain is definitely pumping now. Now, we're talking about properties of special parallelograms. So we're dealing with parallelograms, okay? That means that all the stuff we know about parallelograms, what do we know? We know that the opposite sides are congruent. What else do we know about parallelograms? We know that the diagonals bisect each other. We know that the opposite angles are congruent. And we know that the consecutive angles are supplementary, which means they add up to 180 degrees. Is there anything else we know about parallelograms? Yeah, so all of these things have to do with parallelograms, except we're dealing with special ones. These are very, very special parallelograms. So let's talk about these special types of parallelograms. So, theorems, properties of rectangles, right? So if a quadrilateral is a rectangle, then it is a parallelogram. That's the first one. If it is a rectangle, then it is a parallelogram. And it's just, if it's a rectangle, then it's a parallelogram. Okay, and what do we know about a rectangle? We know that a rectangle has 90 degrees at each angle is 90 degrees. Okay, that's basically the difference. It's a parallelogram with 90-degree angles. So that means all of the other things are true about a rectangle, like opposite sides are congruent. The diagonals bisect each other. Obviously, the opposite angles are congruent because this is 90 and 90 and that's 90 and 90, so that's that. And then the consecutive angles are supplementary, which is 90 and 90, which is 180 and 90 and 90. So yeah. So if a quadrilateral is a rectangle, then it is a parallelogram, which means that opens the door to all of these lovely theorems right here that we kind of just talked about. Okay, what's the second one? It says if a parallelogram is a rectangle, then its diagonals are congruent. Ooh, this is a new one. So if a parallelogram is a rectangle, then its diagonals are congruent. So if it's a rectangle, diagonals are congruent. Ooh, that's kind of fun. So here, AC would be congruent to BD if it's a rectangle. That's not the case with parallelograms, but it is the case. If it's a rectangle, the diagonals are congruent. And since a rectangle is a parallelogram, right, by theorem 641, which is this one right here. So since a rectangle is a parallelogram by theorem 641, which is this one, a rectangle inherits all of the properties of parallelograms that you learned about in lesson 6.2, which are all of these, right? Opposite sides are congruent, opposite angles are congruent, the diagonals bisect each other, and the consecutive angles are supplementary. All right? Perfect. Okay, let's go ahead and look at the first example. Okay. So, let's look at this one. This is example 1. It says it's a craft application. We're looking here. It says a woodworker constructs a rectangular picture frame so that JK is 50 centimeters. And JL, the diagonal is 86 centimeters. We need to find HM. Okay, so it's telling us that JL, that diagonal is 86. We need to find HM. We need to find this right here, just that bit. I wonder how we're going to do that. Now, the key thing that I see is that they tell us that this is a rectangular picture frame. Okay, so we're dealing with a rectangle. And since we're dealing with a rectangle, we know that we're dealing with a parallelogram, right? So what are the things that we know about a rectangle? We know that if we have a rectangle, we have a parallelogram. Okay, and what else do we know? We know that with a rectangle, the diagonals are congruent. Okay, that's cool. So if the diagonals are congruent, and this is 86, then we know that this is also 86, right? And since it's a parallelogram, we know that the diagonals bisect each other, so this HM is half of the whole, right? Okay, so let's go ahead and get started. So the first thing we know is that KM is congruent to JL. Okay, but you know what? Let's go ahead and write a little extra information here because I feel like we're missing something. We need to say that JKLM is a rectangle. JKLM is a rectangle. And that is given. Yes, that is definitely given. What else is given on JL? Yeah, I think that's it. So 0 given. Okay, so it's given in here that it's a rectangle. Perfect. So we know that KM is congruent to JL because if it's a rectangle, the diagonals are congruent. All right, we're going to go ahead and change that format, right? The definition of congruent segments. And then we're going to say what JL is. JL is 86 because that's given, right? We know that. And then what do you think we're going to do? I think we're going to substitute that in there. No, we're not. We're not substituting yet. We're going to say that HM is equal to 1/2 of KM, right? Because if it's a parallelogram, then the diagonals bisect each other. You know what? There should be something in here before this. And I'm going to say, where would it go? Where would it go? Where would it go? Well, that's okay. So HM equals 1/2 KM. If it's a parallelogram, the diagonals bisect each other. And then we just substituted that 86 right there. We get 1/2 86 is 43. That's substitution and simplifying, and boom. There is our answer right there. HM is equal to 43. Okay, do you guys see that? Perfect. Okay, let's look at example 1A. It says the rectangular gate has diagonal braces. We need to find HJ. Okay, so we have a rectangular gate here, and it has diagonal braces. It's giving us GK, and it's giving us JL is 38, okay? What does it say? It's saying that we have a rectangular gate. Okay, so we need to find HJ. So we need to find this. This is what we're looking for. Okay, so the first thing I'm going to say is I'm going to say this is definitely a rectangle, okay? So we're going to say GHJK. GHJK is a rectangle because that is given information. Now, we know that if it's a rectangle, if a quadrilateral is a rectangle, then it's a parallelogram, right? So we kind of want to say that because we know if it's a parallelogram, then we know that the opposite sides are congruent. And if this is 48, then that means that's 48, right? So pretty easy. Yeah, so let's go ahead and state that. So GHJK is I'm just going to say parallelogram like that. Because if it's a rectangle, then it's a parallelogram. Okay, cool. So since it's a parallelogram, we can state that these opposite sides are congruent. So we know that side HJ is congruent to GK, because if it's a parallelogram, then the opposite sides are congruent. Okay, then we just need to change the format, right? This is just definition of congruent segments. And then what? Okay, we have to state that given information. GK equals 48, and that's just given. And then boom, we just substitute it in, and HJ equals 48. Substitution. And there we have it, all right? Perfect. Okay, let's check it out, example 1B, and we need to find HK. HK. What do you think? I think I want to give you a chance to figure this one out. All right, so pause. Here's my friend the pause dragon, reminding you to pause your device. Go ahead and figure out, check it out, example 1B. When you get done, press play and we'll talk about it. All right, see you in a bit. Okay, let's see how you did. So we're trying to find this diagonal, right? And really the only thing that's going to help us is this little JK right here. I'm going to say the first thing they tell us is that it's just a rectangle, right? So let's just state that, I'm going to make it 0. GHJK is a rectangle. So GHJK is a rectangle, and that's just given. Perfect. And then if it's a rectangle, what do we know? We know that these two whatchamacallits, these diagonals are congruent. And since we have this diagonal information, I'm just going to start there. So I'm going to say HK line segment is congruent to GJ. Because if it's a rectangle, then the diagonals are congruent. Then what I want to say is I think I want to play on the fact that these diagonals bisect each other, and they bisect each other because it's a parallelogram, right? So I think I'm going to say that GHJK is a parallelogram because if it's a rectangle, then it's a parallelogram, right? So once I have that, I want to state that GHJK is a parallelogram. Then I can say, you know, I can say that GJ, or I can say that JL is equal to 1/2 of GJ, right? I think I'll just go there. So JL, I probably should have changed the format on that before I stated that. Let's do this. Super easy to do that, Joy. We just go like this. Okay, so I'm going to say HK is equal to GJ because of definition of congruent segments, right? Okay, now I'm going to state that GHJK is a parallelogram because if it's a rectangle, then it's a parallelogram. And then I want to go ahead and state that JL is equal to 1/2 of GJ, right? Because if it's a parallelogram, then the diagonals bisect each other. Okay. Then what I'm going to do is I'm going to substitute HK in here for G. I probably should have done it the other. I probably should have went. Anyways, it's fine. I'm going to substitute. So I'm going to go JL is equal to 1/2 HK. There's probably a couple different ways to solve this. That's just going to be substitution. And then since I know what JL is, it's 30.8. I'm going to go ahead and write down that given information. JL equals 30.8. That's given. And then I just want to substitute that in here. 30.8 equals 1/2 HK, right? Substitution. And then it's just algebra, right? So I'm gonna probably multiply both sides by 2. So I'm gonna go 2 times 30.8 equals 2 times 1/2. That's gonna be multiplication, property of equality, and 30.8 times 2, 16, 1, 6. Oh, so that's gonna be 61.6 equals, those cancel, HK. This is just simplify. And then finally, we just do that symmetric property of equality. Equality, and boom, there we have it. There is HK. So HK is 61.6. So if you got that right, yoka denki mashita, you did a wonderful job, and I'll see you in a little bit for example 2.